Now let's create the get level function to retrieve the NFT level. To get the level of our NFT, we need to use the token ID to levels mapping. We have declared our smart contract passing the token ID we want to get the level for into the functions. So let's copy the function and paste it here. As you can see, that was pretty straightforward. The only thing noted is toString function that comes from the OpenZeppelin string library and transform our levels. That is a u into 56 into a string that will be then be used by the generate character function as we seen before. Okay, so here we are just taking the levels from taken ID levels mapping. Now we'll need to create the get token URI function, generate and retrieve our NFT token URI. So now let's move on. Create a token. Create the get token URI function to generate the token URI. The get token URI function will need one parameter, the token ID, and will use that to generate the image and build the name of the NFT. As always, let's first see the code and go through the different parts of it. Okay. Now let's just copy this function and paste it here. So the first thing you notice that we are using again the encode packed function this time to create a JSON object. Here we are creating a JSON object. If you don't know what JSON objects are, you can read about here. Let's briefly say that our series of keys and values pair the name of the property and the value of the property. The value of name is in this case is chain petals plus number and a token ID to string hash and token ID to string the value of the image property. On the other hand, the value returned from the generate character function. Okay, there it is. Finally, we return a string containing an array of bytes representing the base64 input version of the data URI with the JSON data instruction. Similar to what we did with our SVG image, now that we have created our token, get token URI, will need to create a function to actually mint our NFT and initialize our variable. Let's see how. Create a mint function to create NFT with on-chain metadata. The mint function in this case will have three goals. Create a new mint, initialize the level value, set the token URI. Copy this code and paste it here. So we always first increment the value of our token variable and store its current value to new variable, in this case new item ID. Here we are incrementing it and taking the current value and new item ID. Next we call the save mint function. There it is. From the OpenZeppelin library, passing the message.sender variable and the current ID. Message.sender, the one who's calling the function, and new item ID that we have just get it from here. Then we create a new item in the token ID top levels mapping and assign its value to 0. This means NFT character will start from level 0. Here it is token ID level and new item is equal to new item ID and the level is 0. As the last thing we set the token URI. passing the new item ID and get the value of token URI. This will mint an NFT on which metadata include the image is completely stored on chain. That also means we'll be able to update the metadata directly from a smart contract. Let's see how to create a function to train our NFT and let them level up. Create a train function to raise your NFT level. As we said now, the metadata of our NFT is completely on-chain and we're able to interact with it directly from a smart contract. Let's say we want to raise the level of our NFT after intensive training. To do so, we need to create a train function that will make sure the train NFT exists and that you are the owner of it. Increment the level of the NFT by 1, update the token URI to reflect the training. Okay, this is the train function. Let's copy it and paste it here, and now see the explanation. As you can notice, using required function we are checking two things. Here it is. If the owner of the NFT is message.sender, the wallet calling the function here. Sorry. If the token exists using the exists function from ERC21 standards, here it is. And if the owner of NFT is the message sender, the wallet calling the function as the second condition. Once both checks are passed, we get the current level of NFT from the mapping and increment it by 1. Here it is. Current level and then increment it by 1. That's why calling the set token URI function, passing the token ID and return the value of token URI, token ID. There it is. Calling the train function will now raise the level of the NFT and this will automatically reflect it in the image. Congratulations, we have completed writing the smart contract of NFT on chain metadata. The next step is to deploy a smart contract on Polygon Mumbai and interact with via Polygon scan. To do it, we'll need to grab our alchemy and Polygon scan key. Okay, so let's deploy the NFT on with on-chain metadata smart contract.